Okay, I'm going to go over very briefly some notes on the philosophy of science. It's labeled in our program as epistemology, and I'm hoping everything that is going to work the way it should here. So, uh, okay. So let's start at the beginning and define psychology. I'm going to define psychology as a study of alternative explanations of the behavior of living beings. So we need to get the idea of what do we mean by alternative explanations. And in order to answer that question, we're going to need to say what is an explanation, and that'll be the focus of this lecture. What do we mean by an explanation of behavior? What do we mean by behavior of living beings? We're going to include humans and laboratory rats and monkeys and other animals as well. What do we mean by behavior? We mean the things that the organisms do. And what do we mean by alternative explanations is we mean rival theories of behavior, alternative explanations. So we're going to need to say, what do we mean by an explanation? Now, in judgment and decision making, it's a subset of psychology that deals with certain kinds of behaviors and certain kinds of explanations. So responses are often, but not always, modeled as an implicit, the result of an implicit decision. Why did people do what they did? Because they made a decision to do that. And so they evaluated what are the components of such a decision making. They evaluated what are the possible consequences of alternative behaviors. And they chose one that was, in some sense, the best thing to do at the time. So instead of saying, why did somebody do what they did because of their personality or because of their race or ethnicity or religious upbringing or what they learned to do, we're analyzing behavior as a result of an implicit decision based on the evaluations of the likelihood that their actions would lead to consequences and their evaluation of those consequences. So what are the criteria for explanation? Well, I'm going to need to explain each of these, but an explanation is a set of statements that satisfy the following criteria. I'm going to set forth 5 criteria: deductive, meaningful, predictive, causal, and general. I'll briefly state what these are, and then we'll go over them a little more carefully in detail. So first, you should be able to deduce the phenomena to be explained from the explanation. So it's deductive. We're going to explain why somebody did something. You should be able to deduce that they would, under these conditions, do that. It should be meaningful, and by that I mean it's not meaningless. And we'll define meaning here in terms of the empirical content. So by meaningful, I mean, what is the empirical content rather than definitional or emotive meaning or some other thing. I'm going to be talking about cognitive meaning, which has to do with the verifiable implications. The third criterion is predictive. That means, in principle, if you had known the explanation in advance, you could have predicted the phenomena to be explained. So you can predict, but it's more than predictive. The first 3 are qualify as a predictive system. And if there's time, I may be able to talk about some predictive systems that don't quite go to the next step. And the next step is that it is causal, which means, in principle, if you knew the explanation, you can control the phenomena to be explained. It doesn't mean that you can in practice. It means in principle, you could, if you could manipulate the variables that are the causal variables. And 5, it's general in that the premises are regarded as laws of nature. and not premises that we say are true today and not tomorrow, or for this explanation and not for another one. They have the character of laws that aren't assumed or denied in each case. In other words, they can be used to make other predictions, or they're involved in other explanations of other phenomena in a larger network. All right, so we need to define some basic terms in order to get started. And there are three kinds of statements that we need to distinguish. Definitions. So a definition is a statement of equivalence in the language. We're going to use one word to stand in for many words. A definition is stipulative in a philosophical treatise or in a scientific work. We're going to state the definitions that aren't common, especially if we're going to use a term in a new kind of way. So let's define a bachelor as a human male who's never been married. So a bachelor has to have all three characteristics. And these symbols represent conjunctions. So a bachelor has to be a member of the set of humans. So all bachelors are human. All bachelors are male, and all bachelors are never married. So if a person has been married before and their wife died, we'd call them a widower, or if they are divorced, we'll call them a divorcee. But a bachelor is human male who's never been married. So brand new baby boy, human, is a bachelor, qualifies as a bachelor. Now, an operational definition is a definition that states specifies the operations of measurement. So an operational definition is usually more restricted than a conceptual definition. For example, I used the word human and didn't say how we were going to decide if someone was human. I used the word male and I didn't really define what I meant by male yet. And an operational definition of a bachelor might include our way of measuring it. Now, if you ask somebody if they're a bachelor and they say yes, that might be an operational definition of a bachelor for the purpose of some study, but it may not agree with our conceptual definition, right? Because the person might not actually be a bachelor, they might be a liar, right? But an operational definition is one that specifies the operations of measurement. How do you know if somebody's intelligent? Well, in psychology, we have intelligence tests, and they would each one be an operational definition, and they might not agree with each other. So a person who's intelligent by one test might not be by another. Now, a logical statement is a statement whose truth in principle is known a priori. So a logical statement could be a priori true or a priori false. For example, all bachelors are unmarried is a priori true. Because if you're never married, it means you weren't married before and you're not married now, so you're unmarried. So all bachelors are unmarried is a priori true. The word a priori means in advance, and what's meant by in advance of having to make any observations of the world. You don't need to do a survey to find out if some bachelors might be married. If I were to say all bachelors are married, what kind of statement is that? We know that's false, right? We know that all bachelors are unmarried. And so if I said all bachelors are married, we know that's false, right? It's a priori false. it's a contradiction in terms we don't need to do a survey to find out if it's, to ask if it's true or not. Now, an empirical statement is a statement whose truth is tested. Some people use the word known, but the word known is pretty strong. So I'll just say tested a posteriori. And so we believe that the statement, all bachelors are happy, is a posteriori false. What do we mean by happy? Well, let's define it with an operational definition. We use the standard test of happiness, which is we ask them if they're happy. And if they say yes, we say they're happy by that operational definition. If they say no, we say they're not happy. And if they don't answer the question in one of those two ways, we say we don't know. So a baby bachelor, we say, are you happy? And they go, eh, and they cry and whine. Somebody else might infer by another operational definition they're not happy, but we don't know. And if somebody else spoke some other language and didn't understand our question, didn't answer it, we don't know. And my guess is you could ask bachelors, and it says all bachelors, that's a pretty strong requirement. As soon as we find one that says no, that would say that this statement is a posteriori false, right? So are there a posteriori true statements? Well, we can postulate some and see if we can figure it out. Any questions so far? So those are three kinds of statements: definitions, logical statements, and empirical statements. And a whole lot more can be said about those, but I'm going to jump along. Now, empirical statements have cognitive meaning. People use the word meaning in other ways. A poem might have emotive meaning. You can say the same thing in different ways. And one way of saying it makes people angry. And the other method doesn't make them angry, but you're really saying the same thing. But we're not going to, I'm excluding that right now. We're going to be talking about cognitive meaning and empirical statements. Unlike definitions or logical statements, they have implications that can be tested. So whereas a definition isn't really true or false, it's stipulated. An empirical statement could be a posteriori true or false. And we do empirical tests by making observations of the world. And by the world, I mean the empirical world as opposed to the logical world of the meanings of things. And I'm going to skip over a lot of philosophy. You could take a whole course on meaning and give you the bottom line that a lot of psychologists adopt, which is called operationism. And I'm going to simply state that the empirical meaning of a statement is equivalent to the set of operationally specifiable tests and their outcomes, the outcomes of their tests. There used to be weaker definitions, but this one, but those definitions end up leading you to believe that nothing is really empirically meaningful. And so the meaning of a statement, some statements might have a lot of meaning. Oh, let me go back here. Some statements might have a lot of meaning, and you may not be aware of all of it. But a statement like this, I'm holding up one finger right now, that is a simpler statement than a statement such as, I will hold up one finger for the next 2 weeks, right? Because now you can't check that for a while. Or if I make a statement like, if I drop this, it will fall, is a statement about an infinite number of implications, right, into the future. And so you can't really collect all the evidence for it. You can keep collecting evidence. Well, we'll get into induction in a bit here, but there are some statements that have an awful lot of meaning. And even simple statements can be having surprising amount of meaning. Now, what do we mean by a test? A test is a procedure to obtain observations that in principle could disprove a statement if it's false. Did I start the recording? I did. Okay, good. I'm not seeing any record button lit up, but I'm trying to remember. All right, so a test is a procedure that allows us to get observations that in principle might disprove the statement if it's false. So let's get our first theory of psychology here. This is known as the theory of logically unverifiable brownies. And this theory asserts that everything that happens is a result of the actions of logically unverifiable, and by that I mean untestable brownies. And they have properties. The first property is that they exist. The second property is they're complete, which means that everything that happens is a result of the actions of logically unverifiable brownies. They're also unique. No two brownies are exactly the same. They have inertia, which says that anything that a brownie does, it keeps doing unless it's acted on by another brownie. They're competitive, which is also known as action-reaction, which is for any action undertaken by one brownie, there's an equal and opposite reaction undertaken by another brownie. And there's a principle of dominance, which is that whatever one brownie tries to do and another brownie tries to prevent, the dominant one always wins. So everything that happens is a result of the action of logically unverifiable brownies. So you just reached your eye. A brownie wanted you to do that and made you do that. And another one acted against that. Which one was dominant? The one that actually made you do it, right? So then there's the principle of fringes, which is one that's debatable and people argue about the principle of fringes, which is that illness is produced by the frangulation of brownie fringes. And one thing you got to remember is the brownies are untestable. They're logically unverifiable, which means you can't see them or smell them or taste them, touch them or feel them. And it's a contradiction to assert that someday we may invent the logically unverifiable browniometer that will detect them. It's not like microbes that you can have a microscope and see, because by definition, they're unverifiable. Well, I hope you can dispense. This theory comes in many forms in psychology. And when you take a course in introductory psychology, they'll probably go over several of these theories, with Freud's theory of psychoanalysis and the logically unverifiable brownies that are called the superego and the id, which are cannot be detected. We have enough trouble trying to figure out what's in somebody's mind, and this led to a rejection of introspection, because the question was, in introspection, they asked people, what's in your mind? And then people tried to describe it, and there was quite a bit of argument about we could measure their behavior, we could hear what they were saying, but we had no way of checking whether what was in their mind actually was, because by definition, the mind is private. So that's the theory of unverifiable brownies, and it's in distilled form, many other versions of brownie theory. Oh, I just noticed the recording thing. A little thing is flashing to remind me that I'm recording. That comforts me. Okay. Now remember, the first criterion of explanation was that it's deductive. The second was that it's meaningful. And so we're not going to accept the theory of unverifiable brownies as a meaningful one. because it's not going to satisfy the second criterion. The first one is that it's deductive. And deduction is the use of the rules of logic to go, to follow those rules of mathematical principles, to go from premises to conclusions. And the property that's guaranteed is that if the premises are true, then the conclusion is true. So there are two principles of logic that I'll review here, which are the transitivity of implication, which is if A implies B and B implies C, then A implies C. Another way of phrasing that is all A's are B, set inclusion. So if all A's are B and all B's are C, then all A's are C. So set inclusion is known as a transitive relation. The second principle is that all A's are B is true if and only if all not B are not A. And that one sometimes requires a Venn diagram to demonstrate to people. But remember that A implies B is the same as, or is true if and only if, not B implies not A. So let's see some implications of it. Let's take a look at simple deduction first. Here's one attributed to Aristotle. Socrates is an Athenian, and all Athenians are Hellenes. I'll translate that into English as all Athenians are Greek. And if it's true that Socrates is an Athenian, and if it's true also that all Athenians are Greek, we can reach a conclusion, right? We can reach the conclusion that therefore Socrates is a Greek. So there's a kind of standard deduction, and that uses that first principle, which is the transitivity of set inclusion or the transitivity of implication. Socrates is a member of the set of Athenians, and all members of the set of Athenians are members of the set Greeks. So therefore, Socrates is a member of the set called Greeks. And deduction has the rule that if the premises are both true, then and you use logic, and you shouldn't have to say and you use logic, then the deduced conclusion is true. But if the conclusion is false, it cannot be the case that both premises are true. Might be one is false or the other or both. Or they could both be meaningless. Now, to check your understanding of that, it's a good idea to do the Watson task to check your understanding of those properties. And now might be a good time to do that. I'm thinking we'll take a little, maybe we'll take a little break here, or let's see what happens if I click on this link. See if it comes up and shows here. Well, it does. So here's a task to take, and I would like for you to go to this website and actually do it. You can see the URL right up there. Now, have I asked you to sign up at NeoCities for an account? I might have mentioned it to you before. Well, I will do that now. That'll be good for you. All right. Now, you don't need that account to go there and take this test, but I'm going to review it with you. So there's a deck of cards, each of which has an integer on one side of the card and a letter on the other side. That fact is given, so you can assume it's true. So there's a deck of cards. Everyone has an integer on one side, a number, a numeral representing an integer, and there's a letter on the other side. Now, 4 of the cards are dealt out onto the table. Here's what we see: A, B, 1, and 2. And now we state a conjecture, and by a conjecture, kind of like a hypothesis or an idea that may or may not be true. When you use the word conjecture, you're signaling to your audience that your statement might or might not be true. For these 4 cards, every card with an even number on one side has a vowel on the other. That clear? And the question is, what's the smallest set of cards in terms of a list that we must turn over to test the conjecture? So let's be clear on the definitions of what we mean by a vowel so we won't argue about it later. I'm going to restrict the term vowel to refer to a letter in the set A, E, I, O, or U. I'm not going to include the sometimes Y and various other things like that. And I'm going to say an even number, that's an integer that's divisible by 2 without remainder, like -2, -4, -2, 0, 2, 4, and so on. And what do we mean by a test? We mean an experiment that would refute the conjecture if the conjecture were false. So if the conjecture is false, we'll know it. And so what's the smallest set that we need to turn over to test it? And you can select your answer from the following pull-down list. And notice there are 16 possible answers if you scroll through the list, from none to all 4. And then it asks you to fill in some little things there. And when you're done, you can put a comment in this box and push this button to say you're finished. And so I'm going to take a little break right now. I'm going to stop the share and stop the recording, and then we'll start up in a minute. And I'm going to give you a chance to go fill out that questionnaire. Okay?
Yeah.
All right. So let's see. How do I stop the recording? Pause the recording. I have that. Maybe I should